All right, today we're looking at the product and quotient rule. In the last video, I told you that we'll be looking at ways to find the derivative of things being multiplied together. So right now, our only way to get this derivative is by actually multiplying together. Say x squared times x cubed is x to the fifth, and do the derivative of that, 5x to the fourth. That's not a very hard one, pretty straightforward. But what we're now going to look at is the derivative of two separate functions multiplied together. This derivative is going to be the derivative of the, or let's do it this way. It doesn't really matter the order. The first function times the derivative of the second plus the second function times the derivative of the first. So now let's go back to that problem we just looked at. Even though, as we already said, it's going to be easier to just multiply it together, let's look at it using this product rule here. We'll take the first function, x squared, times the derivative of the second, 3x squared, plus the second function, x cubed, times the derivative of the first, 2x. This gives us 3x to the fourth. This gives us 2x to the fourth. Add them together, 5x to the fourth. So we notice it gives us the same thing we got as when we multiply them together. Now, for many problems, this is not going to be the ideal way to do it. Like, for example, if you have this one, you have a couple options. You can multiply it out, or you can do product rule. We learned product rule, so let's try out product rule. So dy over dx, it's going to be first function. We'll call this 1, this 2. So first function, x squared plus 4, times the derivative of the second, 3x squared, plus the second function, x cubed minus 5, times the derivative of the first, 2x. Multiply it out and simplify, so this is going to be 3x to the fourth, plus 12x squared, plus 2x to the fourth, minus 10x. And so we end up with 5x to the fourth, plus 12x squared minus 10x. Okay. For number 2, this is one where there's only one way to work it. We can't distribute x here and make a polynomial that we can solve. Our only option is to do the product rule. So we have x times sine of x. So dy over dx is equal to x times cosine x plus sine x times the derivative of x, which is 1. Okay? So a lot of this is just practice of different problems. So this one is going to be, number 3 is going to have a little bit more going on. Number 4 has a little bit more going on. So if you want to try those, you can. Let me know if you can get an answer. Next thing we're going to look at is the quotient rule. This looks way more complex. And while it does have more going on, it's not any more complex. This is saying if we have a function divided by another function, we take the denominator, multiply it by the numerator, by the derivative of the numerator, minus the numerator times the derivative of the denominator over the denominator squared. Now, when you do this, you need to make sure that you do it in this order. The multiplication can be in a different order. Like you can switch this and this, but it has to be this one minus this one. You can't switch that part up. Okay? Subtraction has to stay in that order, so we have to keep that. And it has to be the bottom function being squared down there. So let's look at an example here. Unlike with product rule, we can't just multiply it out and suddenly, oh, it becomes easy to do. We're going to have to do quotient rule here. So here's the numerator, here's the denominator. So we take the denominator, 3x plus 5, times the derivative of the numerator, 5, minus the numerator, 5x minus 2, times the derivative of the denominator, so 3, all over the denominator, 3x plus 5 squared. And we'll distribute. Distribute this one in, we get 15x plus 25, minus, distribute this one in, 15x, and then remember to distribute the negative as well, so plus 6 over 3x plus 5. Now we don't need to multiply out this denominator. It's a simplified form by being factored like that. So we end up with 15x's will cancel, 25 plus 6 gives us 31 over 3x plus 5 squared. Number 6 is just more practice with this, so nothing else to add with that one. All right. Now, all of these have division, but not all of them will use quotient rule. So make sure you're being careful about that. This one and this one very easily can be done without. This is the same thing as saying 1/4 x cubed. So when we do the derivative, it's just power rule. So 3 over 4x squared. Same with this one, can be written as 5x to the negative 4. We saw how to do those in the last video or yesterday. Okay. Number 9 as well, even though it is functions being divided, does not need quotient rule. We can just split this up. 3x squared over x is 3x. Negative 10x over x is minus 10. And then 9 over x is 9 over x. So we can split up the fraction and make it 3x minus 10 plus 9x to the negative 1. And that's much easier to take the derivative of. dy over dx equals 3. The minus 10 becomes 0, and then minus 9x to the negative 2. Now, in my class, the one thing you do need to do is you will need to get common denominator here at the end. So 3x squared minus 9 over x squared. There will be problems on the quiz and test that I specifically ask you to use quotient and product rule, but that's more so I can see you work it out. A lot of times you'll just be asked to solve. Now, the other thing quotient rule lets us do is now we can find the derivative of all these trig functions. So sine we've already got, that's cosine. Cosine we've already got, that's negative sine. Tangent we can find by changing it into sine over cosine and doing the derivative of that. And so we have bottom times derivative of the top minus top. Oops. I don't know why I did that. Let me erase. Sine x, not squared. Minus top sine x times the derivative of the bottom. Well, derivative of cosine is negative sine over the bottom squared. Okay, and we end up with, wait, this should have been cosine x. There we go. That'll fix it. All right, we end up with cosine squared x plus sine squared x over cosine squared x. Using our identities, we know cosine squared plus sine squared is 1. And so 1 over cosine squared is the same thing as saying secant squared. You can go through and do all of these as well. So this is 1 over cosine, find that derivative. Cosine over sine, find that derivative. And then 1 over sine and find that derivative. I'm not going to go through that full process. I do just want to go ahead and tell you what they are. So this is going to be negative cosecant squared x. This is going to be secant x tangent x. And this one is going to be negative cosecant x cotangent x. Okay? Good, good. All right, well, that's it for today. I do have one more thing we would have done in class, so if you have a question about that because you're not here, you can come and ask me what that last problem would be. All right, y'all have a great day.